Students, today we are going to verify the logic gate in output. Verify the logic gate output, namely your AND gate with its truth table. By we know the two input AND gate truth table. We have four logical combinations, namely 0 0 0 1 and 1 0 and 1 1, 1 0 and 1 1. So these four logical combination, when it is appearing at the input of the AND gate, what will be the output? According to the truth table we know, but the truth table only we are going to verify through an IC. 7408 is the IC. It's a 14 pin IC, that is a logical 2 input logical AND gate IC. It's a 14 pin IC. It's a 14 pin IC, and of which the 7th pin and the 14th pin, the 7th pin and the 14th pin is given minus VCC and plus VCC, whereas 7th pin is given minus VCC from the regulated power supply, and 14th pin will be given plus VCC from the regulated power supply. So the rest the rest of the pin will available for us is 12, of which 3 pins for a gate. So 2 input AND gate. So 2 pins for input and 1 pin for output. So 12 pins. So you will be having 4 AND gates in that 7408 IC. Okay, 7408 IC. So we know that the truth table of AND gate with two input logical combinations of 0 0, 0 1, 1 0 and 1 1. And we know according to the truth table, AND gate will be 1. You will be having output 1 only for the logical combination 1 and 1. So the rest all for all the inputs, your output will be 1. This and all we know. Am I right? So now how we are going to verify the output? Either the logical 1 is appearing at the output or logical 0 is appearing at the output. How we know is in the voltage level, coming to the voltage level, how to represent the logic 0 and logic 1 in terms of voltages. If it is plus 5 volt, plus 5 volt for this IC, namely your 7408, plus VCC and minus VCC, we will be giving it as plus or minus 5 volt, plus or minus 5 volt from the regulated power supply. So usually the logical 1 will be plus 5 volt and logic 0 will be minus 5 volts. Okay. So when the output of the AND gate will be connected to an LED through a current limiting resistor. So through a current limiting resistor, this current limiting resistor is shown here now. Okay, the current limiting resistor is shown here now. And we know how to evaluate the current, value of resistor. So through this current limiting resistor, we will be connecting an LED. So if the LED blinks, it means 1. Your output is 1. If the LED is off, it means that your output is 0. Okay. So let us continue with the video. So I said this is a current limiting resistor. This is a current limiting resistor. Okay. See, you have an yellow band. The first band is yellow band. The next band is gray band, and the third band is brown band. Okay, yellow band value is 4, gray band value is 7. The third band is a multiplier band, which is brown, that is 1. Okay, 10 power 1. So 47 into 10 power 1, 470 ohm current limiting resistor will be connecting. This can also be verified by using a multimeter. Check here, we are getting around 466. You will be having a tolerance of plus or minus 5 for the quarter watt resistor. This is a quarter watt resistor. So pin number 1, see this already the 7408 IC is inserted in the breadboard. Okay, it is inserted in the breadboard. And pin number 1 and 2 is the input, 2 input of the first AND gate. Pin number 3 is the output of the first AND gate. Okay. So and in the regulated power supply, whatever the two wire leads, blue color wire leads were taken. 2 blue color wire leads were taken. This is the regulated power supply of 0 to 30 volts, and I can vary up to 35 actually. So the left side knob is coarse and the right side knob is fine. See, first we have to switch off this regulated power supply. Up to 35, as I said, we can vary. Coarse and fine, both adjustments are there. and initially it is kept at 0. See, the red color knob is plus 5 and black color knob is minus 5 volt. Minus 5 volt. Now plus 5 should be given at the 14th pin IC. Okay, 14th pin of the IC. So the left side is given starting with 1. Okay, and the 7th pin is at the down, 7th pin. Okay, that is negative VCC. That is negative VCC. Look here, already we know the breadboard connections. Breadboard connection, segment number 2 and segment number 3, all the 4 dots vertically it is connected at same potential. It is connected at same potential, meaning each vertical grid will be at different potential. The 7408 AND gate should also be connected like that. It should be connected, all the pins should be at a different potential. Hence we are utilizing grid number segment number 2 and segment number 3. Okay, segment number 2 and segment number 3 both. One side of the IC, namely from pin number 8 to pin number 14 is in the second segment, and pin number 1 and pin number 7, 1 to 7, it is available in the third segment. Okay, and it is placed horizontally. It is placed horizontally. The notch is here. The notch is here, and we know already in the notch from the left, if left of the notch, that is pin number 1. So you have to come from upside down, and then pin number 8 you have to move from the downside to up, from the downside to up. So 7th pin is given with minus VCC, that is we are taking it from the black knob of the regulator power supply. It is already inserted here. Okay, it is inserted. So now what we need to do, we have to give the inputs and we have to connect the output. For connecting the output, pin number 1, 2 is the input, 1, 2 is the input. So we are inserting 2 wires for giving the input, and pin number 3 is the output. So output we have to connect an LED through the current limiting resistor. So first insert the current limiting resistor in pin number 3. Okay. So each vertical grid connections are at same potential. So pin number 3, the next point I am inserting it. The next, the other end of the resistor can be anywhere inserted in the breadboard, and the LED cathode terminal should be connected. Right, LED, sorry, it is LED anode terminal, plus terminal should be connected to that, to the same potential of the outcoming resistor, and cathode terminal should be grounded, or ground here it is minus VCC. So from minus VCC take a loop wire and connect it to the fourth grid, fourth segment, and I hope you remember the fourth segment of breadboard. 25 dot points will make one potential, and the next 25 points will make one potential. So from 7th pin of minus VCC, you take one loop wire and connect it to the cathode of LED. Okay, so now we need to give the input, because we need to check the truth table for 4 logical input combination. As I said previously, I have mentioned that plus 5 volts will represent high logic 1, and minus 5 volts will represent the logic 0. So already we have given plus 5 volt and minus 5 volt in 14th pin and 7th pin. So we will make use of those 2 pins for giving the inputs to. So first give in the power supply for the IC, you give it 5 volt. Okay, for the power supply you give it, adjust your knob. This is the pin diagram. This is the pin diagram and of 7408 AND gate. See, 1, 2 is the input, 3 is the output. That is what in the 3 we have connected an LED through the current limiting resistor, and 7th pin is ground, which is nothing but minus VCC. 14th pin is plus VCC, and we are going to verify this truth table. Okay, 0 0 0 1 1 0 1 1. Only for this logical, the last logical combination, your output has to be 1. It means that your LED has to blink. Okay, so give by adjusting the coarse as well as the fine knob, try to give 5 volts by using the regulated power supply. Once it is given, so we have two logical combinations. First give 0 0, meaning you have to give minus VCC. Now already see, along with an LED you have looped this minus VCC. So in the same point you give that both 0 0. So LED is not blinking, LED is not blinking. Check here. And now the next logical combination is 0 1. 0 1 and 1 0 both are same. Okay, 0 1 and 1 0 both are same. One if it is available at minus VCC, the other one has to be at plus VCC. Look here, this is minus VCC. See here, the fourth segment as well as the first segment. First 25. Totally there will be 50 dots horizontally. There will be 50 dots in a row. First 25 dots will make one potential. The next 25 dots will make the other potential. All are connected at the same potential, meaning. So now since this LED is connected in the next the second half of the 50 points, so that second 25 lines will make a potential. So here from 7th pin already a loop is connected to minus VCC, and negative of your LED, that is also connected to minus VCC. So that is 0 now for us, otherwise it to be ground. So here one of the input is connected to the ground now, and the other input is available at 14th pin of your 7408. 7408. So when both are 1, this is for both logical combination 1 and both are connected to 14th pin of 7408. I'm sorry, 14th pin of 7408. When both are connected to high, and the LED should blink. It's blinking. Okay, so again it is repeated, 0 0, 1 0 and 0 1 are same, it won't blink, and finally it is 1 and 1. Is it okay? Thank you. The next gate we are going to see is 7432. It is nothing but an OR gate. It is nothing but an OR gate. It is again a 14 pin IC. 14 pin IC. Look here, there is a notch at the top. There is a notch at the top. It's a 14 pin IC. Okay, there is a notch at the top, and you have 1, 2, 3, 4, 5, 6, 7, and 8, 9, 10, 11, 12, 13, 14. This is how you need to go away with the numbers, IC number, pin number. Okay, 7432. See, 7432. Okay, right. So we are going to verify the truth table of this 7432. We are going to verify the truth table of 7432. And it's an OR gate. So you will be having only 1 0 for the first input combination. 0 0, you will be having 0. For the rest, all the 3, you will be having 1. So for all the other 3 input combinations, you will be having 1. So insert at the same point. Again here also 1 and 2, as like your AND gate, 1 and 2 is your input. 1 and 2 is your input, 3 is your output. Okay, 3 is your output. Now give the inputs. First switch on the RPS to 5 volt. Okay. Next gate we are going to verify is 7404. 7404. See, 7404. It's a NOT gate. It's a NOT gate. We know a NOT gate is otherwise said to be inverter. We have single input and single output. When I'm giving 1, we have to get 0. When we are giving 0, we have to get 1. Okay, so that is the one we are going to verify, the truth table of NOT gate. Again remove the IC alone, the logic gate IC alone, and insert this 7404 in the same place, and cross check your truth table. Okay, verify your truth table. So this is 7404, as I said earlier. The 7404, we are the truth table is this 0 and 1 and 1 to 0. And look here, you have a 7th pin to be ground and 14th pin to be VCC, and you have 6 gates now. 6 NOT gate in one single IC, namely 7404. Okay, 7404. This is a logical symbol. And now insert the 7404 in the same place of the previously inserted place. Inserted in the place of previously inserted logical IC. It is being inserted. No other connection is modified. But here we have only single input. Okay, here only we have single input 1. So the second pin is the output. So transfer the connection of resistor and LED to the second pin. That is the only change we have done. Okay, first ground. So if we give 0, it has to blink. So it is given 0, it is blinking. Okay, then give 1. So when you give 1, it is output is 0, it's not blinking. Okay, this is for the NOT gate.